So up to this point, we looked at how to do the basic navigation of the parser hierarchy and how to do basic verifications with the show command. Now we're going to look at how do we actually make changes to the configuration by using the set command in JunOS. Now the set command, like a lot of the other commands we'll see in JunOS, is going to be relative to your place in the particular hierarchy. So if you're under a particular interface and you want to make a change for that interface, you don't need to use the set interface command. You can use it relative to wherever you specifically are. Now, as we talked about previously, when you're moving throughout the parser hierarchy, one of the advantages of JunOS versus iOS is that it always tells you specifically where in the tree of the configuration you're at. So it's not as easy to make a mistake when you think you're configuring interface 1 and you're actually configuring interface 2. In the case of iOS, that would say just config-if, and it doesn't give you details about what specific link that you are located at. So for example here, if we were to set the global host name for the box, we could do this from the root portion of the hierarchy. We could say set system host name, or if we were to edit under the system to move down the hierarchy, we could simply use the set host name command. Now once we actually make these changes, we still need to actually commit the changes. So for example, if we were to go to one of the boxes here, let's say our switch EX1, and if we wanted to give this switch a host name, and right now we can see that we're under the root of hierarchy for configuration mode, we could say set system host name, and we'll call this one EX-1. And if we now say show pipe compare, that's going to tell us what actual changes have we made with this the candidate configuration that eventually will be added to the active config. So this means now if I commit the changes, it's going to add the host name, EX1, and we can see now there's an error where it's going through its basic check of the parser to say, is this a valid candidate configuration that you actually want to commit? Now in this particular case, I haven't yet defined the new root password for these particular switches. So it's saying if you exit out and there's no password configured, you're not going to be able to log back in. So it's enforcing that the root user always has to have a password. Okay, this depends on what particular platform you're working with when you load the factory default and then reload, whether it's actually going to maintain the root authentication or not. So in this case, I need to say to set the system root authentication, and I'm going to give it a plain text password, which means I'm actually typing it in. So type in the password that I want. And then if I say show pipe compare, it says that I'm going to set the host name, but I'm also setting the root authentication. And then also notice what is now going to be deleted. We can see with the minus sign is that those factory default settings are no longer being applied. Because I'm basically making changes, it's no longer the default config. So now if we commit the change, once it actually goes through the validation and then exits back to, or returns I should say, we should see that the host name is going to change to EX1. Now, like I also mentioned, you can do this at lower levels of the hierarchy. So if we were to say edit system, we can then say set the host name. We'll call this one EX2. And we could set the root authentication plaintext password, as opposed to using the full expansion of the command like I did before, which is to set the system root authentication password. So ultimately, you're accomplishing the same thing. It just depends on if there's very deep levels of the parser hierarchy, it might make more sense to do an edit to go down the hierarchy, then do your set commands as opposed to doing them all from the root level of the tree. But whichever way that we apply it, from the root or from that lower level, we always need to make sure to do a commit. Now the opposite of this, the opposite of set is then going to be the delete command. So this is the logical equivalent to the no command in iOS. So if I want to remove an IP address, no IP address in iOS, that would be the delete, then the interface name, the unit, the family, the address in JunOS. But again, just like the set command, it is relative to your place in the parser's hierarchy. So if you were to be at the root level and simply say delete, it means you want to delete everything under that, or basically delete the entire configuration. So here, if we wanted to remove the host name, we could say delete system host name from root. If we were already under system, if we said edit system first, then we could say delete and then whatever that particular variable is. But like I mentioned, the one big thing to remember up here about the delete command is that it's recursive downwards. If you are in configuration mode, so if you're at the root of the hierarchy, and we were to say, first we'll start the CLI, we'll say configure, then show, which again is the equivalent of show run. If I now were to say delete, it says if you say yes, it's going to delete everything under the entire config. If I now say show pipe compare, we should see a minus sign by everything. So it's going to be removing all of these particular commands. If I now commit these changes, and actually we can't commit an empty config, we would have to put something there. For example, like set system hostname srx1 and set system root authentication. Then commit. If we look at the end result of this, then when we show the config, basically there should only now be two statements. Under system there should be the host name, and under system there should be the password for the root user. Now this is one of the other interesting differences between iOS and JunOS, is that you can delete interfaces. You basically can delete anything from the config. It doesn't mean that it's deleted from the system though. So if we look at the show config versus the show interfaces, the interfaces still are there physically. It's just that from the active configuration, they're not actually being used for anything. So this is going to take a bit for it to commit because it's basically checking every single line of the config. But if we were to look at this at a more detailed level of the parser, for example, if we say show interfaces, actually I should have said show config interfaces, because I'm running that command from operational mode. Let's say, for example, that we want to get rid of family Ethernet switching from this particular link. Okay, there's a couple different ways we could do this. We could go to global config first, or configuration mode simply, and then I could say delete interfaces FE002 unit 0 family Ethernet switching. Okay, that's one way to do it. Another one would be to go multiple levels in the hierarchy. So if I go down edit, let's say edit interfaces, edit FE003, edit unit 0, then I could simply say delete family Ethernet switching. And if we show, it's going to show basically nothing because I deleted the option. Okay, if we go up to, let's say, delete FE, actually before we do that, let's say show. So we can see under FE004, there's Ethernet switching enabled. And right now I'm under edit interfaces, so if I want to delete that option, I would simply need to say delete FE004 unit 0 family Ethernet switching. And then if we show, we can see what the end result of that is going to be. Now again, when you're looking at the show here though, it's not the changes that have committed yet. So it says if you save the config, this is what the end result is going to be. Then again, when we want to see the differences between what is currently in the active config, so what's running, and then what is uncommitted, what is the candidate config, again that is show pipe compare. So if I save this commit, it's going to go to that particular interface and it's going to remove these options. Same on interfaces 3 and 4. Now another option besides just simply deleting the config is to use the deactivate command. Now this is especially useful in routing protocol type configurations. Maybe you have like a BGP peer that you want to configure, but you're not yet ready to actually start the peering. You could use the deactivate command to turn the syntax off, but you can still edit all of the other sub options. So the difference is that you don't have to delete the syntax out of the config, you're basically just turning it off or you're disabling it. So if we were to say deactivate protocols OSPF, it's just turning OSPF off, but it's not deleting it from the actual configuration. If we want to undo that, we can say activate and then whatever the particular syntax is. So for example, here, if we were to say in config, let's say set system hostname, and actually I'm under interfaces, so I would need to say top set system hostname. We'll call this SRX2. And if we say we're under edit interfaces, let's say show, that's going to show the config of the interfaces. And let's say for FE005, I want to temporarily turn this off. So let's say deactivate FE005 and commit. And while we're waiting, let's set the rest of the host name. So let's log in as root. Start the CLI. Go to config mode and set system hostname. Set system hostname. We'll call this VSRX1. Okay, so if we go back to the other box that was doing the commit, I deactivated the interface here, which technically is not the same thing as disabling it. Disable under the interface is the equivalent of shutdown in iOS. Deactivate is independent of the type of syntax structure because you can administratively disable interfaces, but you normally can't administratively disable BGP or MPLS. That's what the deactivate command is to do. So if we were to say now simply show, FE005 is still part of the configuration, but it's inactive. So we can still make changes under it, it's just that it's not going to be actually applied to the working config. Okay, there's a couple questions here. Should we commit? Once we deactivate something, you have to commit after every single change. So right now I deactivated the interface. If I didn't commit, the interface is still going to be active. Or likewise, if I delete the interface, it's still going to be available unless I actually do the commit. Now the way that you can think of this is that if you exit out of config mode, where either you could say exit, exit until you get all the way back, or if you were to simply say exit config, you can say exit config from anywhere in the hierarchy and it'll get you back to operational mode. If you have uncommitted changes, when you move from config mode to operational mode, it's going to tell you. Then you could say, no, I don't want to not commit them, and you could show pipe compare and then see what actually is left in the uncommitted config that you have not yet saved. So unlike iOS, you have to save every single change that you make, otherwise it doesn't become active. Okay, another real useful keyword is rename in JunOS. Now, what this is basically used to do is to move config snippets from one section of the parser's hierarchy, move it from one section to another. So if you want to change an IP address, you don't set the IP address because what that would do is to add an additional address to the interface. If you want to change it, you need to rename it from one to the other, or you can delete the old one and then set a new one. But one of the really useful features of this is that if you want to copy, let's say like Ethernet config, if we want to copy the configuration of a trunk link, then we want to, or technically not copy, I should say, if we want to move it from one interface to another, we could simply rename the interface. So in our particular case here, on this box here, SRX2, I had removed a bunch of config that was under FE2, 002, 3, and 4. So let's say that we want to take this config here if we want to move it to the next interface. Okay, what we could do is go to global config, or just config mode, and we'll say delete interface FE002, and then we're going to rename interface GigE001 to interface to FE002. And if we show pipe compare to look at what are the actual changes, what it's doing is getting rid of that old interface and then moving it to the new one. So let's say, for example, you have some problem with the router or the switch and you don't know if the port is bad and you want to move the config from one interface to another. The only thing you need to do is to rename it, have someone move the cable to the new link, and then you could figure out, is it a problem with the cable, is it a problem with the port? It's basically the same as going to the interface and saying no in iOS for every command and then pasting that into another interface. But the point of this here is that it's not specific to the interface level. You can move the configuration, or you can rename, I should say, the configuration from any portion in the hierarchy. So if we look at the show interfaces now, we should see now what we previously had under GigE001 was now moved to FE002. Okay, so this one here, rename interface, that's moving the config from one to the other. If we say rename the address, this is removing the old one and then adding a new one. Because again, the reason why you would want to do this is that if we're in config, and let's say we go to edit interfaces GigE000 unit 0 family inet. Okay, and I'm going to talk about this later, specifically what does this portion mean. I'm going to set an address 1234/4. Okay, so it's assigning an IP address. Now let's say that we commit the config, so we're going to save the changes. And then for some reason we come back later and we want to change the IP address. In the case of iOS, the only thing that you would need to do is issue the IP address command, and it's going to overwrite the old one. But in the case of JunOS, there's no distinction between primary and secondary addresses. And iOS behaves this way for IPv4, iOS behaves that way for IPv6, but not for IPv4. So in JunOS, if we were to say set address 5678/24 and then commit, again, let's say commit and quit, that'll save the changes and then exit back to operational mode. Then once this is done, if we look at the show config interfaces GigE000, which again, this is the equivalent of the show run interface GigE000, we can see it has both addresses. So you would assume that it means to replace the old one, but in the case of JunOS, it doesn't. It's just adding additional addresses onto it. So there's two different options. You can delete the old one and then set a new one, or you can use rename, which is moving it from one to the other. So if I wanted to get rid of 1, 2, 3, 4 and then rename it something else, let's say 10, 11, 12, 13, I could say two different things. We're going to delete interface GigE000 unit 0 family inet address 5678. Then we'll show pipe compare. So we can see that's deleting the address. Also, if we were to say, let me get back to operational mode. If I were to say the terminal, let's see, the set CLI screen width, 1024. Okay, this is the equivalent of the terminal width in the case of iOS. And set CLI screen length, that's the equivalent of terminal length. So when you issue a show command like show config or show run in iOS, it gets to that point where it says more and it stops the output. If you were to set the terminal length to 0 in iOS, or in our case the screen length, set CLI screen length in the case of JunOS, those are basically doing the same thing. Okay, so let's go back to config. And the reason I want to do that is because you could see that command, when it got past a certain width, you were unable to see what it was actually saying there. This is one of the reasons why that as opposed to issuing the set command or delete command from root, you might go multiple levels in edit first, simply because the set command becomes too long. Then it makes it real easy to make a mistake in the syntax, especially if you're doing lots of set. So here in this case, I deleted one of the addresses. If I say show pipe compare, it deleted 5678. If we say show, let's say edit interface, and let me just copy this. We can go to that link, and we'll show. Okay, we're still left with the address 1234. Now I'm going to rename it. Rename address 1234/24 to 10.11.12.13/24. And I need to say to address. So we can see show is saying what's the end result. Show pipe compare is saying what are the individual steps. What it did was to delete the old one. So it is negating or removing 1234/24, and it's adding 10.11.12.13/24. The end result is that when we save, so we're going to commit and quit, go back to operational mode. The end result is that this interface should have one single IP address. It should be 10.11.12.13. Okay, the other option we have is to copy a config, where rename is moving a section from one interface to another or from one protocol to another. Copy, like the name implies, is just taking whatever statements you have under the hierarchy and then making a copy of them to the other interfaces. So this is useful if you want to, maybe you have a templated config, like you have a trunk link with a certain allowed list for VLANs and you want to replicate that to the other ones. You can just say copy and then whatever level at the hierarchy you are, and then to whatever the destination is. So for example, if we were to say on, let's say on one of the EX switches, if we show interfaces, and let's say we were to make a bunch of changes, and I'm going to come back and talk about specifically what are these changes in detail. But let's say that we're under Edit Interfaces, GigE 000, Unit 0, Family Ethernet Switching. And we're going to set the port mode to trunk, set the VLAN members to all, and set the native VLAN ID to 1. No VLAN matches tag 1 for the interface. That I need to create the VLAN actually. VLAN ID, that is the, actually let me get rid of that part for now. Let's say edit the interface, then delete native VLAN ID 1, commit. Then we're under the interface, let's go back up a couple levels, let's say up 2, and show. So now we have a basic templated config, which is essentially saying that this is a trunk link that is allowing all VLANs. So if I want to take the same config and then paste it to other interfaces, I could just copy the syntax and paste it in, but otherwise we can use the copy command directly at the CLI. So if we were to say copy unit 0 to, actually I need to go up one more. Let's say copy GigE 000 to GigE 001, and I would actually need to delete that interface first. Delete GigE 001, 2, 3, 4. And then if I copy the config to 1, 2, 3, 4, basically, it's the same as copying and pasting everything in. Now, again, when we're looking at the show here from configure mode, it's showing the end result in the parser hierarchy with the curly braces. These aren't the actual commands that we're issuing to make these changes. If we want to see what are the specific set commands that were used, we need to say pipe display set after the show command. So let's say that we were to abort these changes for now, which to abort changes we would say, we go to top and we say rollback 0. Then if we were to show config, let's say show config interfaces, pipe display set, this shows the actual commands that we would issue from root in order to actually make those changes. So unlike in iOS, where iOS you can just say show run, copy the config, and then paste it into another box or another section, you can't do that in JunOS because you're not using the same commands to create the config as you are to verify the config. So you can copy and paste it, but the way that you would need to do that is to say pipe display set first, then copy this out, make your changes, like make this giggies 001, 23, whatever, then you could paste it back in and commit the changes. But otherwise, if you don't want to do that externally, that's what we can do with the copy command. Okay, so once, as we've seen for a couple examples here, once you're done making the changes, you have to save them. Now, there's a couple different options that we have for committing the configs. One of them that I was doing was commit and quit. This is saying, assuming that there's no problems and you can save the config, exit back to operational mode. This would be the same as saying commit and then say exit config afterwards. It's just doing it all in one statement. The next one we have is commit check, which is to say don't actually activate the changes, but I want you to check through the parser to figure out, are they valid? Are my commands valid based on whatever is currently in the config? So for example, if we were to go to one of the Ethernet switches and we were to say that it's running IP plus it's running Ethernet on the same interface, it's not going to allow us to do that. It's like in iOS saying it's a switch port, but it's not a switch port at the same time. Those are mutually exclusive configs. So when we issue the command, the router doesn't yet know whether this is going to be valid until it goes through the commit process. So as long as your syntax structure is correct, it's going to accept it, but then you won't know something is wrong until you actually go to do your commit. So if you don't want to wait to figure out what are those actual problems, you can always commit check and then it'll tell you whether your syntax was right or wrong. So for example, if we were to say we want to set interface gigi 000 unit 0 family inet address 1234/24. Okay, so that's setting an IP address. If we say commit check, it's going to look at what's the current running config, so what's the active config, check it against what changes I want to make, and then it says no. In this case, you can't do that because Ethernet switching is on. You cannot be an Ethernet switch port and a routed port at the same time, so it's going to fail. But even if the check was successful, it doesn't actually save the config. So it's not committing it. The only thing it's doing is just checking whether your syntax is valid or not. Okay, the other one is commit at. That's if you want to schedule it for a future time. So commit at, whatever the date and time is. Then the last one, which is really, really useful, is commit confirmed. Commit confirmed is most useful when you're doing remote maintenance of the box, like your telnetted in or your SSH in, and you don't know, are my changes going to break something in the network? So if my OSPF adjacency goes down, I lose reachability to the box, and I can't undo those changes. So I can't manually roll them back. Commit confirm is going to say, save the changes, but then once a defined interval expires, if you don't commit the changes again, they're going to be automatically rolled back. So the way that we would do this is if you say, let's make a change, for example, let's say in config, we're going to set interface gigi 000 unit 0 inet address family inet address 1234/24, and we'll say commit confirmed, and then at what amount of time? So let's say 1, for example. It says commit confirmed will be rolled back in 1 minute. If we exit out and then we say show config interface gigi 000, we can see that change was actually applied. If we look at the routing table, for example, if we show route, we can see that address 1234 is local to the box. It's a directly connected route. It's a /24. Now, once we get to that interval, though, where we have the commit confirmed, if the box has not accepted another commit to say, yes, I actually wanted to save the changes, it's going to automatically undo them. So it's essentially doing a rollback 1 automatically, where rollback 1 is saying, whatever the last change that you made, I want to delete that and go back to the previous active config. Okay, so we can see now it's doing the automatic rollback. Now, beyond this, if you want to roll the config back yourself, when you're in a configuration mode, if you simply say rollback or you say rollback 0, that's saying delete whatever changes that I was currently making and go back to whatever the active configuration is. This is the equivalent of saying abort in iOS XR. So if I go to config and I make a change, let's say delete interface gigi000 and show pipe compare, if I commit this change, it's going to delete that particular link and then whatever's under it. If we simply say rollback, then show pipe compare, it undid that change. So either rollback 0 or rollback, that's the equivalent of abort. If we say rollback and then a specific number, that's going to be based on, in the commit database, roll the config back to whatever that value is. But the thing to remember about this is that you still need to commit after you do the rollback. So if I want to roll back to the changes that I had 5 commits ago and I say rollback 5, I still need to say commit after that and then exit out of global config or configuration mode. We could also, like we've been doing, show pipe compare. That's the one to figure out what are my uncommitted changes. So what changes did I make in config mode, but not actually commit them yet to the active config? That's the equivalent to show config in iOS XR. Now, if we want to compare the differences between different rollbacks, we could say show pipe compare rollback the number. This would be to say, if I were to roll back one change, what would be the result? The result would be I would delete the IP address that I had configured on the interface. If I roll back 2 changes, it would also, let's say 3 changes, it would add the host name, for example. Okay, then you could see specifically how many commits are in the database. So there's 20 commits in there. And who did the commit, so the particular user, and then via the CLI versus like via the web interface, for example. Okay, if we do this from operational mode, so this one here, the pound sign, that's talking about config mode. If we say from operational mode, show config, pipe compare, this is talking about the diff between the active config versus the rollback. When we say this in config mode, it's talking about the uncommitted changes. So if you want to look at the state of the current system versus what would happen when you roll back, you want to say show config pipe compare rollback when you are in operational mode, not in config mode. Now, assuming you don't have any uncommitted changes, though, those outputs would be the same. So for example, if we're in config mode and we show pipe compare, we can see that there are no uncommitted changes. There's nothing outstanding that we've changed. If we say show pipe compare rollback 1, and we exit to operational mode and then say show config pipe compare rollback 1, these outputs are identical. But again, the reason why is that we didn't have uncommitted changes. Now, if we were to go to global config, or just config mode simply, and say set interface gigi001 unit 1 family inet address 5678/24. And then let's look at the same thing. Let's say show pipe compare rollback 1. This says that if I did the rollback, I would be negating the address on gig 0, but I would be adding the address on gig 1. This is different than if we said show config pipe compare rollback 1 in operational mode. And the reason why is that this here with the plus, this was uncommitted. So if you want to look at what's the current active state versus what the rollback would be, You need to make sure to do that from operational mode, not from config mode. If we say show system rollback, that's going to show you the full configuration. That's from operational mode, show system rollback 1. So that shows the full config in what's called the stanza output that shows these little curly braces. If we said show system rollback compare, that would be show me the full diff between two different rollbacks. So show system rollback 1 compare 2, or rollback 0 compare 1. This is saying the difference between what I have running now versus what would happen if I rolled back to one commit. It's going to delete that particular address. But if I were to roll back between 1 and 2, that was the change that was made between the two of them.